behalf of our organizing committee and government for attending to, let me introduce Sir Dr. Mohan Verma, sir, is a well-known physicist and material scientist, currently working as a professor and head of department of applied physics and Shankaracharya Technical Campus, Bhilai. He has more than 25 years of teaching and research experience. Sir has established one of research lab, computational nanomaterial research lab is in fact first computational research lab in the central India and working as research mentor of national international PhD scholar of
welcome back. Welcome back.
Sir is highly accomplished in the field of computational material physics and he was in close collaboration with the various national international institutes for various research projects. He has continued his research on various emerging technologies like polymeric electrolytic materials and designing electrodes in the form of nanotubes and nanobelts for different electrochemical and optoelectronic devices, solid-state battery, supercapacitor, sensor, biosensor, organic light-emitting diode, biosolar cell, and light-emitting electrochemical cell. He is author of 10 plus research papers in various reputed journals, out of which 50 plus are in DFT-based material modeling. Sir has guided to 15 PhD candidates in experimental and DFT-based theoretical studies on electrochemical and optoelectronic materials. Sir has various international collaborations and organized many international and national conferences, workshops, and continuously giving training to DFT-based tools to national and international faculties and scholars. He has one of school of DFT under the scheme of skill development and informal education of Swami Vivekananda Technical University is running successfully in which more than 120 participants have been trained, out of which 20% participants were out of India. Sir has developed 30 plus invited count in various national and international conferences and workshops. Sir is active life member of several professional bodies like National Society of Solid State Ionic Material Research Society of India, the Society for Advancement of Electrochemical Science and Technology, and is passionate about contributing to scientific development through his research activity. I welcome you, sir, on behalf of our organizing committee and Government Polytechnic Group for this session. Sir, please.
Thank you, ma'am.
This afternoon session, we have rice and roti to make to Aida. So I request Hina madam to come and please be seated in the first row or the second row. And sell from the last video, please. And sit along with your teacher. And so much, sir, please. क्योंकि बालकनी की नसीब सबको नहीं होती, बालकनी का मजा नहीं। Thanks. Now I'm handing over the mic to Verma. Yes.
Yeah, correct. Okay, so thank you, Chaco sir and Dr. Rachana for the short invitation, and I'm always ready to interact with the learners. If you are a good learner, then I will be a good instructor. So a long introduction is given by that conductor of this program, and thank for that the good introduction. I'm Dr. Mohan Verma, and this is, I think, my 11th such lab session in this specific tool. So mic on नहीं है, ये mic में है. Anyway, so I think my voice is okay. There is no issue with that mic and other things. Anyway, so as informed by Dr. Rachana, this is one interdisciplinary faculty development program. And there is some mechanical people, electronics and telecommunication people, and electrical people are there. And also she tries to collect some people, some other subjects also, but that few physics people didn't give any response to her, and I'm sorry for that. शायद उन्होंने मुझसे ठीक से नहीं कहा होगा, अदरवाइज कुछ फिजिक्स पीपल तो मैं यहाँ अपने इस इसमें ले आ रहा था. So if we think about that interdisciplinary approach, then we have only one thing that is very important, which actually connects the different branches, different subjects, and that is then finally called as interdisciplinary. That is one is the properties of material. One cannot imagine about the world without the properties of material, and that mechanical people, civil people, also that electronics and telecommunication, electrical, all these peoples are connected with material. So this tool which I am going to introduce here, that is actually related to study the properties of material, and that materials in the nano region. So I am actually the person of nanotechnology, nanomaterials, and since my work is now focused on the DFT, so this is that DFT based tool. So that computational material science one can say. Basically मेरे introduction में ये होता है कि during my PhD I was purely experimental pupil, and after completing my PhD I switched to mathematical modeling, and then finally I switched to that computational one. And nowadays this computational field is a very, very important field, and all the experimental pupils as well as that theoretical pupils are trying to learn that DFT based tools, DFT based studies. Anyway, so what is the difference between that experimental material research and the DFT? I generally say this DFT based studies as computer experiments. One term is nowadays being used as a computer experiment, means that experimental term is being used by the computational people. So this is the computer experiment. So in the experiment, especially that material based experiment, what we do, we just search materials either through literature survey or other things, and then we design or prepare that material, then we characterize that, and then finally we create the device, we fabricate that device. These are the 3 to 4 steps of that material research. First, searching that material, suitable material, then that preparation of that material experimentally by using different methodology, and then the characterization of that materials after preparation, several properties. There are so many tools are there to characterize that material, and after characterization, if we get that suitable material for any specific device, then we fabricate that device. This is the term. Similarly, in a DFT based studies also, we design material. So that the preparation part is shifted to that designing part. We design the material, and then we characterize the material with different properties, and then we fabricate a device. But all these things are on the computer screen before fabrication. So we generally help experimental people to fabricate that device with the study on the computer system. Although initially this was known as just a simulation, and the people were thinking that simulation is just like a computer game. No, it's not a computer game. This type of study is purely quantum chemistry, quantum physics, or physics based studies, where we study all the properties very accurately. Earlier, my initial students, when presented some papers in some conferences that DFT based studies, then that experimental people generally pointed out that what is this? What type of study this is? What if you are doing? Nothing is this. So many errors are there. DFT is nothing. But now those people are coming to my lab and requesting to just verify their experimental result, and this is the success of my lab. This is the success of this DFT, and last 15 years I am working with this field, and now here with you. So now how to start? Question is how to start. One thing you should know about that the computer, the mouse, keyboard, screen, and everyone knows. And that Microsoft person, that the leader is just captured all the market, and now we people are working on Windows. But for this type of computational studies, we generally use one effective operating system, that is the Linux operating system. So you should know about Linux operating system. Then again the question is, how much Linux we should know to learn a DFT? Not much. It's very easy. 3 to 4 commands. Initially that was really very difficult, that this Linux operating system is too typical, it's a command based operating system. But no, this is not true now. It's just as user friendly as Windows. So the hesitation of using that Linux operating system, it's now just overcome. So please, you can start Linux operating system. Each and every packages are free of cost, and you can use that Linux operating system as Windows. For example, let us see. This is that whatever that screen it is shown here. This is that desktop of my Linux operating system. I am using Ubuntu 20.04. So I think this is that the screen is similar to that Windows one. Same desktop is there, although some interactive graphics might be there. But this is that screen, and that file systems and other things are same. One can use Windows, Excels, and other PDF files and other things like that. One can use mouse as similar to that our Windows operating system. So is there an issue? So that left click, right click, and everything is here and here. That all the information related to my laptop is this is my computer system. So I generally say that my lab is always with me. This is my lab. I'm using one single laptop. I can run any computational program up to 50 to 60 atoms in my simple laptop. So my lab is always with me. This is that the configuration is not much high. People think that without HPC one cannot run that DFT based studies or that simulation material modeling tools, one cannot run. But no, this is not true. Even you can, using simple desktop, here in this desktop we try to install some virtual box things, and I will show how to run that, and you can start running. So this is my operating system and other things, and you can start using this as like a window operating system. And here that this is that the simple Excel systems similar to that. You can use this one, and that window also, everything. So if just using your operating system, that Windows operating system for Microsoft Office, Excel, and that PowerPoint presentation, then you can use this, and this is more effective. Its tools are more effective. You can directly convert PDM and other things, and without spending any rupee. Okay, so this is the things, and तुमने जूम कर दिया या मुझे कैसे दिए होगा? हाँ, पूरे टूल्स है। नहीं, आप ये मॉनिटर देख लीजिए। अच्छा, यहाँ से देख सकते हो। ठीक ठीक। Anyway, so one additional thing that is I could not say, I cannot say that additional thing. This is also in Windows also, and that one is the command window. So here we will use some command, and as I mentioned that we need not to know all the commands, because that copy, paste, and other things, there are all these are command based in Linux operating system. But you can copy just like window, you can paste just like window, you can cut, everything is there. Only thing, there is some specific command for to run any specific tool. This is important. And if you want to start, then I have one YouTube channel for help that beginners, that is Sister India. And recently I introduced there one 5-minute talk for beginners. And there I have one lecture on how much Linux, the knowing Linux is important for DFT, to learn a DFT. Just a 5-minute talk. Go to that. And if really if you have HPC or that supercomputer type facility there, yeah, that supercomputer facilities are purely command based facilities. There you need to know much Linux. But for if you are using that a desktop or laptop, then simple that ls one command, this you have to say this, all the files and folders, single command, and then some more commands, 3 to 4 commands. If you are able to use, then you can run any tool. So this is the first thing in computational material research. You need to know few commands on Linux, and even you can take the help of Google. There is some problem, and there are also lots of numbers of videos are there in YouTube, some basic commands, Linux commands. So 4 to 5 commands if you know, then you can run a Linux operating system easily. Then next, after learning Linux operating system, the next step will be some designing tool. You have to design material, but before designing material, you have to search that material in various database. So we have a good database for material research, and that is the material project. This is a very, very good database, and you can start exploring material. So before using any material for any device, for example, this particular FDF program is dedicated to your HEV, and there we need to learn about batteries, supercapacitors, and if you want to use that HEV or in that research in this field, then you should learn it. As far as that material properties is concerned, you should know about the electrolytic properties or electronic properties of material, and especially that supercapacitor and batteries. We know that electrical people, electronic people, and simple physics people, you know that batteries is the composition of electrodes and electrolyte. Anode and cathodes are there, and there is one electrolyte. Somewhere we are using some membranes. So we have 3 to 4 components in supercapacitor or battery. If you are using the same electrode, then it's a supercapacitor, different electrolyte and some membranes, it's supercapacitor, different electrodes and that electrolyte and membrane, then we have that battery. Nowadays there are some advanced level batteries or batteries research are running in this field, and that is this hydrogen based batteries, that is known as fuel cells. Fuel cells is also advanced in recent just ethanol based fuel cells, methanol based fuel cells, some more chemistry is involved here. But the thing is, we must have to learn about that properties of electrodes, electrolytes, and that interfacing between electrodes and electrolytes. And in this type of study, this tool is enough. So before starting any material, just literature survey. After surveying that literature, you can get some materials, and also you can search here by using this material project. So here there is one dashboard and communities are there. Yes, battery explorer. So here that different battery materials are they given, that calcium based materials are. So these are that one material that is related to calcium battery. So one battery explorer and related properties are mentioned here. So you can select any specific material. So you can select any specific material and start studying. So first thing you must know about few commands of Linux operating system. Second, you have to search material. So you can go any good literature, and also you can search this material project or other database available in internet. And my recommendation is this is a good database. So how to use this material project? One lecture of 5 minutes is also there in my channel. So you should follow that. You should go there and watch that, because everything cannot be covered in 1 hour and 15 minutes. So I am just giving the glimpse. So the material project is a very good database, and how can you use, and the flexibility of this material project I have mentioned there within that 5 minutes. Then now we know about something about these materials and what actually we have to study. The next step will be that designing of that material. We know about that material or its component, then the designing of that material. And for designing, we use some tools. And one thing that I would like to mention here, that is each and every tool which I am going to use or I use, that is free of cost. It's a Linux based, that is free of cost. So I generally use to design that material that is known as ZDIAs. So that how to install that and how to use that. So here, to open that, you can use this command. And also, if you don't want to use that command, then this all the softwares are listed here, and you can click here and open that. But after some run, you can feel that this using commands, some commands, it's easier to just search that particular device on computer screen. So this is my ZDIS tool, and I can design different nanomaterials, nanostructures by using this tool. So the third step, that is that designing of this material, and this is very effective tool. And how to use that? So all the things, other things are that file, edit, tools, view, maximum are just window based. One can click here and open similar to that window one. So let me start with one simple atom, and that is available in my silicon. Wonderful material, Silicon Valley, silicon based solar cell, and really this has a very good property, and this is one of the unit cell. So that in the chemistry physics, one term is used as unit cell. So we can start working on that unit cell, and this unit cell have that crystalline structure, hexagonal structure. So this display it's a hexagonal structure. So one thing, by using that tool, even one can start using this 4 atoms to analyze the properties of any bulk material. Bulk material is not that you have to take a very big material. We can start working with starting with this one unit cell, and this is the 4 atom unit cell of silicon. We have a different view in a different direction. So along this, this tool has a good property in that. So this is one phase, the second phase, and this is that top phase. So if you want to study that bulk properties of this silicon, you can start with that 6 silicon hexagonal structure, and you can download this structure. I have downloaded this structure from material project. This structure is not designed by me. I have downloaded this unit cell from material project, and I have started opening this. And now I can modify its structure. This is just a ready-made structure bulk, but I want to convert it in form of planar structure, because nowadays that maximum device are thin film based devices. experimental people are creating thin film. So that thin film is actually the planar structure. We can convert this in form of a planar structure. So let us have, I'm going to convert this. I've just extended its length in two other directions. So this is that planar one, but it's not completely planar. I'm just creating that supercell. Sorry, something is wrong. Let me open again. So I just open this, and this is that unit cell, and now I am extending its dimension in to other direction. And then I am converting this in form of planar. It has different layers, but in the planar structure we must have a single layer. So I can delete that upper part and the lower part, and in DFT based calculation, so all these are as easy as this is that thin film that experimental people are knowing this as a thin film, and this is just a planar structure, monolayer. This type of terms are used by computational people. We use this as a monolayer, planar structure, two-dimensional structure. So this is just a simple designing by using a single tool, and one can start working on that. We can have different layers, one layer, two layer, three layer. If you want to increase that its a thickness, then we have to increase the layers. But if we want to have just the mono layer, single layer, then one can start working this. Even many times we observe that its a property has drastically changed when we transform from bulk to monolayer. Many systems, even the silicon, it's a metallic, it is showing metallic properties in bulk. But when we convert in form of that thin film or that planar structure, it behaves like a good semiconductor. Many times. Many materials have shown this type of properties change. So you can study the change in the properties by changing its structure, and that structure change that will be on the computer screen. Even one can design that nanotubes. So let me design some good, very famous. What is happening? Everyone knows about this carbon nanotube. This is that carbon ring, and when we increase its length, this becomes carbon nanotube. We can make, this is single wall carbon nanotube. We can design multi-wall carbon nanotube with the same tool, that is the multi-wall nanotube. This is double walled, and we can increase its size, and this is multi-wall nanotube. So if you want to design that, then I think in a computer system, this ZDI should be available, and you can try yourself if you want. Anyone interested, or just a demonstration is okay? Yeah, quantum ATK, but its cost is about 13 to 14 lakhs. Yeah. Yeah. So that ATK and but my motto is हम इंडिया में रहते हैं और जितना फ्री में हमें अगर मिल सकता है ATK तो इतना खर्चा क्यों करें? सो बहुत सारे डेमोन्स्ट्रेशन लैब वालों ने, मतलब बहुत सारे कंपनी वाले लोग ये करते हैं, डेमोन्स्ट्रेट कराते हैं, but the cost is starting from 6 lakhs to 14 to 15 lakhs in different modules and other things, and it's too much. Without any big project, one cannot even think about these tools. And if it is easily available in internet with this Linux, that is a window based and Linux based both. Yeah, so this is very good. So this is nanotube. Even we can design some mixed nanotube. This is carbon nanotube, MS nanotube. So we can design boron nitride nanotube like. So let me use one more. I'm just changing. So the need of this designing is we need to change that chemical composition and the bond length between these two. I am trying to design here that boron nitride. So Bn, this is also one of the material comparable to graphene. It's a property. Graphene is zero band gap semiconductor, and it's a good band gap semiconductor. So as far as that the device application is concerned, this boron nitride, this is a very much useful with compared to that graphene. So this is that nanotube Bn, and let me try one carbon inside this. So let me use that Cn. So that inner part of this nanotube is Cn, and upper part is Bn. So this is the freedom of the computational research. If you can think anything, you can design. That inner part is some more material, and upper part is some other things. Otherwise, that in experimental people have that multi-wall nanotube, that is carbon nanotubes or boron nanotube separately. If they want to make the composite, then they have to mix that material. But here we can create this using this. Yeah, looking beautiful. Polymer can be designed also, but not in the same tool. This is for the crystalline structure. If you want to design nano ribbon, if you want to design nanotube, if you want to design planar structure, then you can use this. For polymeric material, we have some more tool. So that is Zamol. This is for the molecule. This is Java based tool, and this is also free of cost, and one can even visualize that crystalline structure by using this. But for designing it, we can use this tool, and one of the famous structure that is people randomly I have connected six carbon, created random bonds, one molecule. I don't know what is actually this molecule is, but for the molecular designing, one can use this. You have to click that atom and click on that screen, and automatically this will connected, and you will have a good material. So for polymeric material, you can use this. For crystal material, we have so many other utilities, and one of that GDIS is one of that good tool. So for crystalline structure, I use ZDIS. Any question?
Most of us are mostly from electrical side.
Yes.
तो ये थोड़ा समझ तो नहीं आ रहा है, बस एक चीज़ है क्योंकि इलेक्ट्रिकल व्हीकल से रिलेटेड है, तो जैसे हम लोग नैनो का वर्ड तो सुनते आ रहा है, तो सम पार्ट इट मस्ट बी रिलेटेड विद आइदर कैपेसिटर्स या नैनो सेल्स, तो कैसे थोड़ा सा जैसे कैपेसिटर अगर बनाना है तो कैसे अरेंज करते हैं कि जैसे कैपेसिटर में अपन पढ़ते हैं एप्सिलॉन ए बाई डी, डिस्टेंस कैसे कम कर देते हैं।
अच्छा,
हम लोग इलेक्ट्रिकल के हैं,
नहीं ऑब्वियसली
VLSI भी नहीं पता है, नैनो भी नहीं पता है और इसी का यूज होता होगा। और इलेक्ट्रिक व्हीकल में कैपेसिटर्स और सेल
बैटरीज एंड
इसमें नैनो का कैसे क्या है, ये थोड़ा सा जानना चाहते हैं।
सर आपको क्वेश्चन है सब सुनने दीजिए,
ठीक है।
बाकी लोग भी क्वेश्चन सुनने दीजिए कह रहे हैं।
सर प्लीज रिपीट।
My question is that
माइक ऑफ है क्या?
how this nano electric materials are related with formation of capacitors, in which we can prepare a large amount of capacitance using a small thickness or distance.
Good.
Second, cells.
Cell batteries, yeah.
हाँ, ये नैनो का कैसे यूज होता है, थोड़ा सा हम लोग जानना चाहते हैं।
Done. Yes, good. So the nice question, and generally that the people, that engineering people's doing simulation, they are just connecting different components on the computer screen. There are several tools they are using, so that electrodes are there, that circuit designing are there, and they are connecting here and there, and find that characteristic. And for that they are using MATLAB, Simulink, and other things are, and this type of tools are. But here, this tool, this is basically the material properties based tool I am going to introduce here. And when we think about that supercapacitor designing, then we have to study its components. So in the supercapacitor, we have, as I mentioned in the just beginning of this talk, that for the supercapacitor, what we need electrodes. So by using that nanocapacitors or capacitors, if you want to study that, then we have to design that nanomaterial for the electrodes. So the properties of that electrodes we can study by using this tool. Okay, so that we cannot fabricate or design on the computer screen, this is that good electrode. But we can give the properties of that electrodes, the capacitance, even that quantum capacitance type studies we can perform using this. So that by using calculation, we can have good nanomaterials with specific properties related to capacitor.
तो वही चीज नैनो मटेरियल से नैनो की है क्या, थोड़ा सा ये आइडिया है, हम लोग समझ पाए, वो थोड़ा सा ऐसे ही हम लोग जानना चाहते हैं।
सर मैं मोटे तौर पे पूछना चाहता हूँ, नैनो पे इतना क्यों फोकस किया गया?
Yes. नैनो पे एक टर्म जो जनरली यूज किया जाता है, दैट इज दिस सरफेस एरिया, एंड मैक्सिमम जो प्रॉपर्टी जो होता है दैट इज द सरफेस डिपेंडेंट प्रॉपर्टीज ऑफ द डिवाइसेस, the contact. If the surface is good, connection will be good, its characteristic and properties will be good. Okay. So when we change the design, size, shape, when we just transform from that bulk materials to that nanomaterials, means we try to enhance its surface area. So when we increase the surface area, contact increases, and obviously its properties increases. Even that simple bulk material jo hai, we are having capacitor, that is the bulk capacitor. When we move to that supercapacitor, means we have to use nanomaterials to increase that surface area. So this is the things, that nanotube or whatever that nanomaterials we are saying here, just to increase its surface area, because we are changing that the shape. Even that the characteristics is, we can calculate that capacitance by using this tool, because in capacitor what we measure, just capacitance, capacity, and that capacity is divided in two parts, that bulk, that total capacity, that is related to its quantum capacity. So when we think about that nanomaterial, then we can calculate quantum capacitance. So by using this tool, which is a very electronic level tool, we can calculate quantum capacitance. So these are some terms used in this research, although that is not the bulk research, but that is the nano research. So that material, on the basis of size, we can say it's a nano, and it is 0 dimensional, 1 dimensional, 2 dimensional, 3 dimensional. Here different dimensions we have. So if you are thinking about that 0 dimensional, there is one term, that is quantum dot. Solar cell people are using quantum dots, that 0 dimensional material. That is also known as nanoparticles. These are the terms.
So for this, what are the necessary parameters which is known to us, so that we can
For supercapacitor,
Yes.
especially for supercapacitor, you have to calculate its capacitance, and also that stability of that material. Because if you are designing some material, then stability is very important part. So the stability of that material, and one more thing that one should study, that is the interface properties between that electrolytes and electrodes. And electrodes are basically electronic material. That's why we are using this tool. Electrolytes are just your ionic materials. So that electrode materials are purely electronics, and all these materials, maybe polymeric materials, are just simple metallic materials. So that is good conducting materials. For the batteries also, that electrode and electrolyte. So we study that components by using this tool. And for that one, we have to design that material and then study. We have to start studying. Okay, I tried. कह नहीं सकता कि मैंने सेटिस्फाई किया कि नहीं किया, क्योंकि बट आई ट्राइड.
आपने जो ये स्ट्रक्चर डिजाइन किया, इसके क्या क्या पैरामीटर्स वहाँ पे इंसर्ट किए, ये पूछ रहा हूँ.
इसमें सिंपल एक मैंने इनपुट फाइल लिया है मटेरियल प्रोजेक्ट से, मैंने ओपन किया, उसके बाद फिर इट्स ऑटोमेटिकली गिवन इन दिस टूल, इट कैन सेट. मैंने क्लिक भर किया है. मैं इसको जस्ट एक विंडो की तरह यूज करना चाह रहा था, और कुछ नहीं है. विंडो में जैसे हम तो डिजाइन करते हैं, वी कैन यूज दिस एज अ विंडो. आई जस्ट क्लिक हियर एंड देयर.
What freedom we have got in editing this structure?
Yeah, you can add, cut, copy. Just one can connect. Just click here and there, and you can connect.
We can alter the distance.
Yes, we can. We can alter the distance. Even one thing, that is, actually this is a chemistry-based tools, so that energy parameters, it is taken care of. Even that valency, that carbon, that valency, I just when I click here, automatically this tool carbon is here. जैसे मैंने क्लिक किया, इसने कार्बन, ऑटोमेटिकली इट गिव्स 4 हाइड्रोजन्स. 4 हाइड्रोजन्स, इट्स स्टेबल.
हम लोग इसको जब पढ़ाई करते थे केमिस्ट्री रट के जाते,
Yeah. Because we know this, as far as the chemistry is concerned, carbon has 4 valency. So this is already set it. Material properties. So for the material properties, we know this carbon has 4 valencies, so 4 hydrogens is automatically added. When we connect one more carbon with this, yes, double band. So automatically that number of hydrogens it reduces. Even that bond length, this bond length, when we optimize its structure, bond length is set it. As far as the chemistry or the material science, we can measure this bond length, and that is we can compare with it's about 1.34 angstrom, and then that is single bond, double bond, triple bond, it's starting from 1.2, 1.34, 1.54. This type of measurement is given in chemistry, hydrocarbons, saturated. Yeah.
Now, how to measure the different parameters?
Different parameters. Which type of parameters?
Like we are interested in some electrical properties.
Electrical properties. So in electrical properties, you want to measure. Actually, this tool is a totally energy based tool. Optimum energy we have to calculate, and for this after optimum energy calculation, we have some formula, and we can put that, and we can calculate. So this tool actually optimizes that structure and gives some parameters, fundamental parameters: energy, bond length, bond angles, and other structural parameters. Density of state, this type of electronic distribution, this type of properties it is given. Okay, so just search my channel, and there everything is mentioned. Yeah, yeah, sister India, there is the yes. Sister India hands-on tutorial on molecular modeling. Yes, you want to dope something. In one playlist recently I have added go to playlist, and here, yes, hello everyone, I'm again here with one more new topic, that is the atomic simulation environment, ASE. This is one very good environment, and it is compatible with different DFT based tools. So in this short talk, we will discuss about what is actually this ASE is. The complete playlist will deal with this ASE GUI, and this is for the designing and other things. 5-minute DFT playlist. Deal with this. So one can start. So, let's begin. Here. So as usual, let's continuously go to that web page, that is ASE with the system. Let me open this web page. So this is about. So this AAC is atomic simulation environment written in Python programming language. So this is Python. It has and so this the aim of setting up is studying and analyzing atomic simulation. Yeah. Why not? Yes. Doping is when there is one lecture in this playlist also for the doping, but I should show you here. This is that planar structure. We want to dope something, then click here. Sorry, just editing, add atom. So atomic doping is here. Yes, and you can change the name. For example, I want to dope here silver. This is that silver doped in a particular. So that doping is actually two kinds. One is just you can replace any atom, or you can add. Here I am adding silver on that surface of this silicon monolayer. If I want to dope inside that one, so I can replace this also. So I can click here, yeah, and change. This is that silicon. So I can change here. Sorry, adding this. It's just doping, and let me open that one new model. So in this bulk I am just trying to dope increasing the size. So if I want to replace this, and I can change this one. If you want to dope this, so this is now the copper here. So silicon is being replaced by copper. So in a specific position one can replace any atom. So I just dope this copper in the this bulk silicon. मैंने वहाँ पे प्लेनर लिया था, प्लेनर में मैंने एटम ऊपर चाहो तो आप एडिशनली ऐड कर सकते हो, या यू कैन रिप्लेस. So that this is that method. Even you can create that defects, some defects properties. So just click here and then delete. Yeah, defects is created. So the change in the properties in the presence of defects, change in the properties in presence of any foreign elements, foreign atoms, or change in the properties in the replacement of any atom we can study for any type of material.
Is this overlapping or replacement?
Just a replacement.
Not overlapping.
Not overlap. I just replace one silicon with copper. अभी सिर्फ डिजाइनिंग है, फिजिकल पर अभी सिर्फ डिजाइनिंग है, अभी हम उस टूल तक नहीं पहुंचे हैं. ये स्ट्रक्चर हमने डिजाइन कर लिया. देन कंप्यूटर इज एक्चुअली द डम बॉक्स. वी हैव टू गिव ईच एंड एवरी इंफॉर्मेशन टू दैट कंप्यूटर. तो यहाँ पर हम एक इनपुट फाइल क्रिएट करते हैं, and that input file is created by this. So here when we save this, one input file is created, that is input.fdf, and this fdf, this is a flexible database, and I have created that, this one. So this type of input file is created by this tool, and this input file we can use with that sister tool. So sister is a main tool जिसमें हम लोग मटेरियल ऑप्टिमाइज करते हैं, डिफरेंट प्रॉपर्टीज हम लोग लेते हैं. For that main tool we have to design that material, and we have to create input file, and all the properties related to that species, for example silicon, copper, we have to provide. So if you want to run any specific program, then we need to, I think I think here it should be there. So these are some properties. I should show you what type of properties we can study. So this is that zero dimension material, bulk material. We can calculate its optical properties. This is one dimensional material. We can calculate its band structure, band plot and other things by using that tool. This is two dimensional nano ribbon. We are using this band gap and other properties, even that magnetic properties. So all these magnetic, electrical, electronic properties we can use. We can study. This is the bulk material. And also this molecular switching, that electrical people, if anyone interested to start that molecular switching type behavior, one can study. So that switching behavior, we can, when we rotate in any specific molecule, its properties changes, IV curves changes, that molecular switching. So this is one molecule that is known as ketosone. So when I rotate one monomer with respect to other one, its properties is being changed. This is IV curve. So this type of properties is known as switching property. And nowadays one term is used, molecular switching. So this is that the change in the properties in the twisting of that molecule. These are some properties, that ionization potential, electron affinity, chemical potential. So these are that electrical parameters, some global softness, hardness. So by using simple formula, one can study these properties. So I just wanted to show you that sister run. Anyway, so here let me just show you how to run that. So this is one input file generated by GDIS, and this is CNANR, armature nano ribbon, containing 8 number of atoms. So how this actually looks like, we can open using this. So this is one simple unit cell of a nano ribbon, armchair nano ribbon. Carbon and nitrogen is there. One small unit cell I have designed, and then by extending this I can convert this into a nano ribbon. So this is that nano ribbon, two-dimensional material. So I can design this unit cell, convert this into in form of that nano ribbon. So I just want to show. So this is that input file, and there are two other files, that is PSF file. This is known as pseudo potential file. This is actually the information of that elements related to carbon and nitrogen, all the informations, that valence electrons and that core electrons, everything is there. And if you want to run that, then a single command I need, that is so by using a simple command that the program will run. So you have to install this system, you have to design that that structure, create that input file. Method is simple. After optimization, there will be some output files that will be generated and you have to analyze. For example, if you have that XRD data, same data, then what you did after that? You analyze that result. So we have to analyze that result, that bond length, bond angles, and that is a energy and other parameters. So it depends on your computational power. This will take a few minutes. So what is the meaning of this parameters given, and one can have a good literature, good books on that DFT. Internet, that Google, ChatGPT, these are available to help you. So everything is there. So one can start learning that, and this will be easy then. So that electrical people can start working on that batteries, supercapacitor, and especially that electrode materials. And nowadays, one new battery, that is zinc air batteries. It's in the picture. So that zinc air battery, one can start working on zinc air battery. One of the electrode is replaced by air, oxygen.
What are the challenges? Like in a graphic design, we can design a molecule or something else.
Yeah.
By combination of those different molecules.
Yes.
What is practical scenario in the real life? How we can design that molecule?
Actually,
What are the challenges behind that?
challenges is main thing is, if you are designing that material, means that if you are testing its stability, if it is a stable material, then just talk to that industrial.
Molecules will be different.
Yeah.
Their melting point will be different.
Yes, yes. You can measure. You can give.
You cannot combine them by mixing at a single temperature.
Yes. Even there is nothing randomness. Basic that physics, chemistry, material science, everything is there. You can calculate its thermodynamical properties. You can calculate its melting point and everything. So if you are theoretically calculated, then you can say that experimental people to design this material because this is stable enough. Main thing is, challenge is to get that specific property up to that level. Sometimes if you are designing some material and its melting point is less, and you want to increase its melting point, then you have to do accordingly.
Tool will help you analyze the things before designing a product or particular
Yes,
molecule.
up to electronic level.
It will save time,
Money, yes. We generally suggest people.
or characteristic of that particular molecule after designing. So you will analyze it in the software.
Yes, even because that experimental things are sometimes it's error in error based studies. If you are designing something and it's showing error, and then you are redesigning. So before going to that design, you should study all the properties on the computer screen. This is simulation.
Best possible working condition.
Best possible, optimum. That's why this is known as optimum condition.
So what are the minimum variation between the experimentally obtained values and the parameters which we are getting from this computation?
No, there is not much difference.
At par, 5% variation, 2%, 3%.
It's sometimes it depends on whatever that computational parameters you are taking. Sometimes its band gap is underestimated, 4 to 5% less. So even there is some more tools to compensate that. So generally we have some reference material. We have some reference material.
It will be better than 90%.
Yeah.
90% or more similarity will be there.
Yes. It shows. Yeah, it shows 95% similarity. Even some better ideal conditions are there. We are actually using ideal conditions.
Even if it is 90, it is
More than
as good as ideal.
yeah. Anything else? बोर किया क्या मैं?
मजा आ गया। सर ये लंच के बाद वाला इतनी जग रहे हैं।
So actually, if you are interested, you can start with your laptop. If you have laptop, I have shared one link to Dr. Rachana, and you can install that this tool in your virtual box on your window. Okay, So even that pupil, that lay pupil is there, and he can help you. So that in the virtual box, everything is installed. So tomorrow we can work on any specific material. So that will be more interesting. I just today this is just a demonstration. Okay, and before that you can go to you should go to that channel and at least watch 5 to 5 minutes, 4 to 5 lectures. That will be easy. Yeah. चलिए, इसमें होना ये चाहिए था कि सबको बताना चाहिए था कि आप अपने लैपटॉप तैयार करके रखिए. हाँ, तो 3 to 4 hours hands on session. It's कंटिन्यू रनिंग सेशंस आर देयर. 1.5 घंटे में तो बहुत कम होता है, इसमें तो कहते कहते. Yes, Dr. Chaco. So should I conclude? Time is there. So it's just yeah, that. But here I can directly I cannot jump to battery because I'm introducing that tool. Okay, so that in the electrode material, if you want to study that battery type things, then what we have to do? First, let me show you that. For battery, actually, specific electrode materials is, we think about that this type of reaction. There is one example, that is lithium ferrous silicate. This is one of the electrode material. और हम जब बैटरी के परफॉर्मेंस की बात करते हैं, then we just think about that transfer of electron and to that electrolytes, and this type of calculation is performed. So this is that OCV, open cell voltage, we can calculate on the basis of this tool, for which what we have to do, we have to design this after take that structure of LiFeSiO2, SiO4. We have to study its energy, optimum energy. So that value, that E, it is that energy. And second, then it is with this equation, when it is adding with the lithium and some electrons, it is giving some additional output. So we have to think about this type of cell reaction. Battery में cell reaction की बात की जाती है, different electrodes. So we have left electrode, right electrodes, and we think about that cell reaction. So we study that cell reaction. On the basis of that cell reaction, we calculate that OCV and other parameters. So before going to that final output of that battery, we have to study that materials and that reaction, battery reaction, anode reaction, cathode reaction. तो यहाँ से इलेक्ट्रॉन निकल रहा है, एनोड इलेक्ट्रोलाइट के थ्रू आगे बढ़ रहा है, इस तरह की बातें की जाती है. इवन that one कैलेशन वोल्टेज इज कैलकुलेटेड ऑन द बेसिस ऑफ केमिकल पोटेंशियल. तो अगर आपको बैटरी अगर कोई डिटेल से ये करना है, देन यू शुड नो अबाउट दैट केमिस्ट्री बिहाइंड दैट. So we can perform some chemistry on that. Directly we cannot design just to pick one anode and cathode. So that type of simulation is different. This is material simulation. So these are some materials designed by this pupil. Yeah, battery का पूरा, हाँ. Yeah, if you have one cell, then you can yeah, आप कर सकते हो. Theoretically एक बताया हम, we can calculate theoretically how that output will, that cell will give, और उसके बाद फिर आप कैलकुलेट करके देख सकते हैं इसको सीरीज में जोड़ने से कि आपको आउटपुट कितना मिलेगा. आपको एक यूनिट सेल का आपको ही मिल जाएगा. इवन आप इलेक्ट्रोड मटेरियल चेंज कर करके अगर कोई आप किसी सेल का परफॉर्मेंस अगर देखना चाहते हो, तो किस इलेक्ट्रोड मटेरियल के लिए बेस्ट होगा, हमारा सिलेक्शन ये होता है कि हम बेस्ट चीज देना चाहते हैं. दिस इज नॉट रैंडम. आपने एक के लिए चेक किया, आपको आउटपुट मिला, दूसरे के लिए आप थोड़ा सा मटेरियल चेंज करके देखिए, दूसरे के लिए आउटपुट मिलेगा. जो बेस्ट होगा दैट आप उस मार्केट को दीजिए, उसको बोलिए, इंडस्ट्री वाले बोलिए आप इससे आप डिजाइन करिए. So that lithium is okay, still in the market, but very soon that sodium, calcium, और आजकल तो एक नया टर्म आ रहा है, that is जिंक बैटरीज. So air batteries, ये भी कुछ जगह हाँ so होने लगा है. That is this is that zinc battery, zinc air battery. One electrode is air, तो यहाँ पर आप लिथियम सोडियम आप यूज करिए, बहुत बेहतरीन आउटपुट दे रहा है. एंड these outputs are theoretical calculation. It's given as 2.91 on single. You can connect in series. Single. And second one is that oxygen air battery. So it is under study. हालांकि बहुत ज्यादा इसमें फैब्रिकेशन नहीं हुआ है, बट दिस इज अ वेरी गुड टॉपिक टू रिसर्च. HEV आने से इसमें लोगों का इंटरेस्ट बढ़ गया है इस तरह के बैटरी में. इवन द पीपल आर ट्राइंग टू सम गुड फ्यूल सेल्स. These are some chlorophyll based solar cells. These are that fuel cells. इसमें भी आपको हर जगह आपको जो स्टडी करनी है, दैट इज द रिएक्शंस ऑन द एनोड एंड कैथोड. एनोड और कैथोड में जो रिएक्शन हो रहा है उससे आपको आउटपुट कितना मिल रहा है. सो दैट इज डायरेक्ट इथेनॉल फ्यूल सेल. बहुत अच्छा आउटपुट है इस फ्यूल सेल का. स्टिल दिस इज इन द रिसर्च स्टेज. एंड हियर इसमें जो इमिशन वगैरह हो रहा है, दैट इमिशन इट इज नॉट हार्मफुल. वाटर देता है. दिस इज डायरेक्ट इथेनॉल फ्यूल सेल्स. हो सकता है नियर फ्यूचर में इसका इस्तेमाल किया जाए इन HEV. या मिथेनॉल इज फ्लेमेबल, इट्स इनफ्लेमेबल. ये हार्मफुल नहीं है ज्यादा. मिथेनॉल बेस्ड जो फ्यूल सेल्स हैं, आई हैव कंपेयर्ड समवेयर. या दिस इज दैट कंपैरिजन. ethanol, hydrogen and methanol. Its efficiency is still less than that hydrogen and that methanol based fuel cells. कार्बन डाइऑक्साइड प्रोड्यूस करता है. ये कार्बन डाइऑक्साइड प्रोड्यूस करता है एज अ बाई प्रोडक्ट, बट इट्स गुड. तो नियर फ्यूचर में इथेनॉल बेस्ड फ्यूल सेल्स. और इथेनॉल के साथ एक चीज ये है कि इवन छत्तीसगढ़ में लोग इथेनॉल प्रोड्यूस करने के लिए पीछे पड़े हुए थे. हाँ, वी कैन प्रोड्यूस. जो वेस्ट मटेरियल्स रहते हैं, क्राफ्ट्स के जो वेस्ट मटेरियल्स रहते हैं चावल से बनाने के लिए पीछे, तो हाँ इजीली इट कैन बी इजीली प्रोड्यूस इथेनॉल. तो कास्ट पॉइंट ऑफ व्यू से दिस माइट बी गुड. हाँ, ट्राइबल्स यूज करते हैं. यस, इथेनॉल बेस्ड जो फ्यूल सेल्स हैं ये फ्यूचर में छत्तीसगढ़ पॉइंट ऑफ व्यू से गुड. हमारे पास बहुत इथेनॉल जनरेट कर सकते हैं. हाँ, वो आप ये चेंज कर देख सकते. एक छोटा सा वीडियो है, आप देखिएगा. उसमें जेमोल पे है कैसे डिजाइन करना है. मैंने एक्चुअली उसमें बता दिया है कैसे कैसे करना है ना. तो एक बार देखिए. कल फिर मेरे को 1.5 घंटे बुलाएं. कल फिर उसको रिफाइन तरीके से करते हैं सिस्टमेटिकली. आज तो मैंने सिर्फ ग्लिम्स दिया है ना, क्या क्या किया जा सकता है. ठीक है, कल फिर एक स्पेसिफिक मटेरियल को लेकर के फिर हम उसको. हाँ, आप लोग लैपटॉप लेकर के आइए. जितने लोगों के पास लैपटॉप है, हम इन लोग को लिंक दे दीजिए, या फिर पेन ड्राइव में अगर कोई, क्योंकि उसमें जो वर्चुअल ये है दैट इज अबाउट द साइज इज 3.5 GB, 3.6 GB. मेरे ड्राइव से लिंक्ड है, उसको डाउनलोड करना पड़ेगा. और उसके बाद फिर मेथड दिया हुआ है, एक छोटा सा मैंने वीडियो बना कर दे दिया. इवन दैट इज इंस्टॉल्ड इन द 2-3 सिस्टम. सो कल अपन इसको ये करके इसमें रन करा के दिखा सकते हैं. चलिए.
For now, sir, I would like to thank Dr. Verma, who came here very short notice, and tomorrow also he will be available for
चाको.
the lab session.
हाँ,
Thank you once again.
चाको सर के लिए तो कुछ भी.
Now we will be having article review session. So the article has been shared in your WhatsApp group, and the sheets will be distributed to you shortly. And for that, we will be preparing groups of 6 persons. So 6 persons, 6 groups. I am calling on the name, and you please be seated according to your groups. Marathi sir, Hitesh Baradia sir, Ajay Kumar